So after today's lesson, I understood that we were having some trouble with lesson 3. So what we're doing today is we're going to finish up homework 3 tomorrow in class. Lesson 3 is what you're doing tonight, and we're going to do this right into your cumulative notes. So this would be the cumulative notes for lesson 3. The only thing I do not have here that you want to add are any of the formulas, the rules, and you want to have anything, the steps for graphing a linear equation. So please add those before or during this lesson at any point to really get your lesson 3 so it's up to date. The first thing we're going to do is we are going to get the following 3 in standard form. So feel free to try them and then continue on. You are not being an active learner if you just copy them. So I would take a step and then I would see where I go and see if you go in the same direction that I do. And if you don't, then go back and figure out what went wrong. So you can do step by step, or you can just follow along. But if you follow along, remember that is not active learning. That's just passive learning, where you're getting what I'm giving you. So try to change this so you're doing it actively. So go ahead and begin and use this however you need to. I will continue forward throughout the whole thing. I would pause and try throughout the entire video. Okay, so the first thing I have to remember is I need to get this in standard form. So ax plus by equals c. I'm going to look back at the rules, so you should do that right now. I'll keep referring to them. So the first thing is I want to get my x's all together, and I want them to come first. So the only x I have in this problem is 9x, and it's already first, so that's in a good place. Now I need to get my y's all together. So I'm going to go ahead and subtract y from both sides. Underline, I bring the 9x down. I owe 2, I owe 1, that means I owe 3 y's, equals, they cancel off, negative 15. Now I ask myself, is it a negative number? It's not. Are all 3 terms divisible by a factor? Yes. 3 comes out of 9, 3 comes out of 3, 3 comes out of 15. So this gives me 3x minus y equals negative 5. Now, at this point in time, is there anything else I can do? Are these all integers? They are. A is not negative, so at this point I know my a is equal to 3, my b would be equal to negative 1, and my c is equal to negative 5. Number 2. When I look at this, there's a whole lot of problems. First of all, I have a negative coefficient. Second of all, this is a fraction. So there's lots that I can take care of. I'm going to do one at a time. Some of you might try to do 2 things at the same time, and that would be okay. The first thing I'm going to do is multiply through by that 2 because I can't have a fraction. So I'm going to multiply both this side and this side by 2. When I multiply this whole side by 2, I distribute it into each one. This is where that tool comes in handy again. So I'm going to go ahead and get negative 8x minus 2 times 1/2 gives me negative 1y equals 6. Now the fraction is gone. That's the first step. The second step is I have to get rid of the negative a. So I'm going to divide every term by negative 1. So this is going to give me 8x plus y equals negative 6. Now it goes through all the rules and none of the rules will be broken. A is equal to 8, B is equal to 1, and C is equal to negative 6. These are all linear. Everything's good in the world. Now I look at number 3. Now, do I have all my x's together, first of all? Well, there's an x. It's combined with a y, though. Is there any way to make this x and this y become plus instead of multiplying? As far as I know, there is none. This is already separated. This is already separated. Those are good, but this over here is a problem, and I can't take care of it. There's nothing I can do to solve it. So this one is not linear. And it's important to understand which equations are linear and which ones are not. Now down here, we're going to go ahead and we're going to graph the following. Now, when I graph, I have to remember that I'm going to choose a domain, and it's going to have to be reasonable. So before I can choose my domain, though, I have to understand the equation a little bit better. And one of the things I do to understand the equation a little bit more is I find the y value, or the dependent variable, and I get it all alone. So I'm going to come over here and I'm going to solve my equation for y. So I'm going to do solve for y. So I'm going to rewrite this problem, 3y equals x minus 6. I'm going to divide every term by 3, and that would give me y is equal to 1/3 x minus 2. So now when I'm creating my reasonable domain, I'm going to think about numbers that are going to be divisible by what number? I have y is equal to 1/3 x minus 2. So what number am I going to want to have it be divisible by if I have to multiply x by 1/3? What kind of x's do I want to put in? Well, I know I want 0 in the middle. So I'm going to think, what number would be divisible by 1/3? 1 is not, 2 is not, but 3 is. What about 6? Yep. What about -3? What about -6? So that's a reasonable domain. It's easy to see around 0. I'll be able to see what's going to happen. So I'm going to come over here and I'm going to substitute that in. Y is equal to 1/3 of 6 minus 2. 1/3 of 6 is 2. Minus 2 is 0. Next, y is equal to 1/3 of x minus 2. I'm going to not put x there. I'm going to put 3. 1/3 of 3 is 1 minus 2, -1. Y is equal to 1/3 times 0 minus 2. Those cancel off, and I get -2. Again, remember, you only have to tell whatever you need for yourself to be able to create your table. So 1/3 times -3 gives me -1 minus 2 gives me -3. So I'm checking over here and I see a pattern. I should get -4 here if all's good in the world. So I'm going to come over here. Y is equal to 1/3 times -6 minus 2. This gives me -2 minus 2 is -4. So now I'm going to go ahead and plot this. Now again, I'm going to think about my graph. And I don't have a lot of space for my graph. But my x's have to get all the way up to 6 and all the way down to -6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I don't have a lot of places for that. Now, the other thing is my y's have to go down to -4. So I'm going to go up here a little bit, and I'm going to think about how I'm going to change my graph so that I can fit them all on. So what I might do is, I know that I'm going to plot 0, 3, and 6. So what if I make each one go by 3's? This one would be -3, -6, -9. But whenever I change the scale, I would also have to change the scale on the x-axis. Now, I may not make it by the same, so you saw that on the other day when you were doing the fundraiser. These scales may be different. Now my y goes by 1's, so I can keep that by 1's. I'm going to make that 0. I'll make this -1, -2, -3. This would be 1, 2, and 3. I do want to go ahead and write 3 above and 3 below when I change the scale, because it's going to make sure I graph them correctly. It's going to help me read my graph. And it also tells the person reading your graph what you're writing. So this is 6, 0 is my first point. So I'm going to plot 6, 0. It stays right there. 3, -1, 3, -1. So at 0, I go down to -2. At -3, I go down to -3, and at 6, I go down to -1. Now, what I'll notice, to -4. What I notice is that this forms a line. If for any reason it doesn't form a line, then I would ask myself, is the equation linear? Could this be put into standard form? Absolutely, this can be put into standard form. So this is a linear equation. This should be a line, and mine is. Now I put the name of it on the graph, so that would be 3y equals x minus 6. Okay, I hope this helps. I hope I covered a little bit, some new stuff as well, just by talking about the scale. Add this to your cumulative notes, and we'll finish homework 3 tomorrow in class. Have a good night.